metal joining part 2. Okay. In the last week, not last week, the week before last week, I think I have discussed you about this pressure gas welding and shielded metal arc welding and gas metal arc welding and flux core arc welding, right? And those things I have covered. Okay. And today onwards, we will try to. Today we will try to cover the from this submerged arc welding onwards. Okay. Today's topic is submerged arc welding. It's a type of arc welding, right? It's a type of arc welding, and in this submerged arc welding, we are using uh, granules, right? Granules of material. Okay, granular flux. We call that known as granular flux, right? Welded arc is shielded by a granular flux. You can remember in the shielded metal arc welding, right? In the shielded metal arc welding, we have some kind of flux, right? We have used some kind of flux to cover the welded area, right? Same function is done by this granular flux. ඔගොල්ලන්ට මතක ඇතිනේ ශීල්ඩ් මෙටල් ආක් වෙල්ඩින් වලදී අපි පාවිච්චි කරා ෆ්ලක්ස් එකක්, right? ශීල්ඩ් මෙටල් ආක් වෙල්ඩින්, ෆ්ලක්ස් කෝ ආක් වෙල්ඩින් ඒ වගේ අපි යූස් කරා ෆ්ලක්ස් එක, right? ඒ ෆ්ලක්ස් එකෙන් කරේ welded area එක cover කරන, right? So that is the purpose of the flux. Same achievement, right? Same thing is achieved by using granular flux, right? In the submerged arc weld. Okay. So we have some granular flux, right? It's made of these lime, silica, manganese dioxide, right? Likewise, some combined material. Okay. Then the main purpose of this granular flux is this flux prevents splatter or sparks, right? The splatter means, you may have seen this in the arc welding, this sparks are splattered, right? මේ arc එකේ හැදෙන එක busy වෙන, right? හැමතැනම busy වෙන, right? So you can prevent that splattering by using granular, right? Granular flux. Okay. I will show you how we can achieve this. Okay. Act as a thermal insulator to promote the deep penetration of weld. Okay. So if you cover the welded area, right? So this granular flux, they have less thermal conductivity, right? They are not thermal conductive. They are not thermal conductive material. They are thermal insulators. Therefore, you can retain the entire heat in the generated within the weld, right? අපි දැන් weld කරද්දී හැදෙන heat එක තියෙනවනේ, ඒ heat එක retain කරලා තියාගන්න පුළුවන්. අද වගේ තියාගන්න පුළුවන්, right? ඔයගොල්ලෝ දැකලා තියෙනවනේ අර දරලිප, දරලිප දැකලා තියෙනවා, right? ඒ දරලිපේ ඔයගොල්ලෝ දැකලා තියෙ ගිනි අඟුරු, right? ගිනි අඟුරු වැහිලා තියෙනවා අලු වලින්, right? එහෙම වැහිලා තිබුණාට අර ඇතුලේ තියෙන heat එක එහෙමම තියෙනවනේ. අන්න ඒ වගේ තමයි, right? So same thing. Okay? High productivity compared to shielded metal arc weld, right? So it has a higher productivity, right? Because it has a deep penetration, right? The weld, it has a good quality, right? It has a good penetration and it has a good quality. Okay, so you can see high productivity, 4 to 10 times with respect to shielded metal arc weld, and weld speed is high as 5 meters per minute, right? විනාඩියකට මීටර 5 කියලා කියන ගොඩක් ලොකු ස්පීඩ් එක. Equipment with multiple electrode. In here we are using multiple electrode. Okay, so we feed the wire and we melt and we cover the weld area by using this flux, right? Granular flux, and we supply voltage and current to melt the wire, right? So that it will be deposited as the weld area. Okay, weld area deposit in the within. Okay, I will show you how this submerged arc weld is done. Okay. Sorry, I will share the sound. I think sound is not there, right? You can see these granules, right? They are made of usually, I think, manganese dioxide, likewise, different combined material. Okay. Also, you can observe that spark, right? මෙතන උඩ බලා ගන්න පුළුවන් spark එක හැදෙනවා. ඒක ඇතුලේ තමයි weld එක හැදෙන්නේ. Also, this additional granules, right? It will be suck, right? ඒක එකතු කරනවා. suction එකෙන් ඇදලා ගන්න. So you can see the quality of the weld, right? We're going to pay a quality එක මේ. But it has a good I mean, good profile. Right. So that is the submerged arc welding, right? එකිනෙක අහලා තියෙනවා දෙවෙනි එකෙන් කරන්නේ රත් වෙච්ච එක නිමන එකද කියලා. නෑ. ඒකෙන් කරන්නේ මේ අර වැඩිපුර අපිට ඕන කරන granules ටික තියෙනවනේ ඒ ටික ඉතුරු කරලා අනිත් ටික ඇදලා ගන්න. මෙන්න මේ part එක තමයි. Right? මෙන්න මේක තමයි දෙවෙනි part. Right? So the function of that part is to for suction, right? For suction, and you can remove additional granular flux. Okay, so that is the function. Then the next thing is the next type of arc we are going to discuss is electrogas welding, right? Gas welding. So this by using this electrogas welding, you can weld vertical plates, right? සිරස් විදියට තියෙන plates අපිට පුළුවන් weld කරන්න. Right? So that is the electro gas welding. Right? Used for welding vertical edges Special machines are required. The weld thickness is 12 to 75 millimeter. Okay, so in this electrogas welding, we supply, I mean, similar to previous welding methods, right? Culling weld karpu method වගේම තමයි. We provide the welding wire from this part, right? The welding gun. Then to cool that welding process, we supply water to cool down, right? Then after that, okay, right. I will provide a clear ones, okay. Then we provide another set of water, right? I mean, in this one, we use this shoes, right? අපිට කියන shoes කියන, right? ඒක තියෙන අර weld area එක ඒක රඳවගෙන තියාගන්න. weld කරපු ටික රඳවගෙන තියාගන්න, right? So that is to retain the molten metal or the molten welded part. Okay. So we use water to cool down that fixed shoe as well, right? And also we provide shielding gas uh, to reduce the oxidization, right? To prevent oxidizing welded area. මේ welded area එක oxidization එක නතර වෙන්න අපි shielding gas එකක් use කරනවා. And usually the shielding gas is usually carbon dioxide or argon or combine gas. Okay, right. I think I have included a video as well, right? How to do this electrogas welding. Okay. Right. Electrogas arc welding is a consumable electrode type welding method developed to enable vertical position welding of thick cut plates at high efficiency through stable penetration, right? So you can use electrogas arc welding for that purpose, right? For vertical position. The shielding gas used in electrogas welding is mostly carbon dioxide. But argon gas or mix of argon and carbon dioxide, oxygen or helium are used as well, right? අපි ඒ වගේ ඒවත් use කරනවා. For welding wire, flux cord wires that form slag to create nice bead mostly used, but solid wires also used in some cases, right? Yeah, you can remember flux cord wires, right, in the previous lecture. Okay, so similar types of wires are we are using a similar types of wire. Okay. The welding power supply is a DC constant voltage characteristic power supply or DC constant current. Okay, a characteristic power supply, right? We usually use DC current. DC means the voltage and current it does not change with the time, right? කාලෙත් එක්ක current එකයි voltage එකයි සාමාන්‍යයෙන් වෙනස් වෙන්නේ නැහැ. Okay. The process encloses weld pool with the end of base metal, a copper shoe, and a fire resistant backing, and performs upward vertical position welding while preventing the dripping of molten metal. Right. So by using that shoe, right? By using that shoe, we can retain the molten metal, molten welded material, right? Weld කරද්දී ඕන මේ කියන්නේ මේ material එක තියනවා melt වෙච්ච ඒක රඳව ගන්න shoe එකේ. The advantages of fast deposition rate through the advantages are fast deposition rate through the use of large current, high efficiency, and a relatively large margin for groove accuracy because of the small angular distortion, right? So those are the advantages. So you can achieve higher building speed, right? You can achieve higher rate. Okay. So these types of these are electro gas welding and submerged arc welding. They are using it for large application, right? Because it will consume more time and cost if you are using a method like shielded metal arc welding. Okay, so that is the reason. Then electro gas welding is used for welding vertical butt joints of products such as ship shells, bridges, storage tanks, and pressure vessels. Right? You know these ship body, bridges, storage tanks. They are large in size. Therefore, you have to use you have to do it quickly, right? Otherwise, it will take longer time. Okay, so you cannot. It will be very difficult to use a method like gas metal arc welding. Okay, then electro slag welding, right? Electro slag welding. We are using this electro slag welding for welded thickness higher than 50 millimeters, right? Plate thickness, right? Plate thickness එක millimeter 50ට වැඩි ඒවා. So in the electro slag welding, what we are doing is we try to melt the wire and we are passing that molten metal through a slag pool. Okay? ඔගොල්ලෝ මතකනේ අර flux එක right? ඒ flux එකෙන් හැදෙන එකෙන් හිතන්නකෝ flux එක නැත්නම් slag එක උණු වෙලා තියෙනවා. Right? Flux එක උණු වෙලා තියෙනවා. Right? The slag is uh, in the liquid state. Okay, so we are passing molten metal through the slag pool. Okay, so that it will be deposited under the slag pool. The slag pool and the metal pool, or that slag and metal, the molten metal, they have their densities are different. Therefore, the slag will be floating on the molten metal. A slag එක නැත්තම් ඒක අපි ගන්න පුළුවන් slag එක මෙල්ට් වුණාට පස්සේ ඒකේ ඩෙන්සිටි එක අඩුයි right එතකොට අර මෙල්ට් වෙච්ච මෙටල් වල ඒක පාවෙනවා මොකද ඩෙන්සිටි එක අඩුයි right so you can form the molten metal pool right molten metal pool in the bottom මෙන්න මේ වගේ right this is the molten metal pool and this is the slag pool okay right arc start between the bottom of the weld and electrode tip right so here this arrangement is little bit different you can remember right ඔගොල්ලන්ට මතක ඇතිනේ කලින් ඒ වගේම we provide the electrical power right we usually power, for example this one right we usually give the electricity right for the welding torch or welding gun likewise right but in this situation you can see we have given the positive polarity for the wire and the negative polarity for the welded area right ඒ දෙකේ තමයි power එක දීලා තියෙන්නේ okay the arc start between the bottom of the weld and the electrode tip okay in the bottom of the weld and electrode tip flux is melted by the heat and the slag reaches the tip of the electrode arc extinguishes right flux is melted by the heat and slag reaches the tip of the electrode extinguisher right which means uh, I mean the amount of right the flux is being melted and this slag pool is formed before this molten pool is formed right මේ molten pool එක හැදෙන්න කලින් මේ flux එක දිය වෙලා මෙන්න මේ වගේ slag pool එකක් හැදෙනවා ඊට පස්සේ තමයි මේක deposit වෙගෙන යන්නේ right I will show you how it happens right And this is how they load the granules over the flask. Okay?
Já apagou o arco já, Tito. Olha lá, ó. 450 pés, 30 volts. Forma a fossa, ela apaga o arco e fica derretendo energia.
Esse abriu e já estabilizou, né?
Bambador lá embaixo. Temperatura lá embaixo. Nossa. Já tô encostando ele queimando.
Ficou perto daquela lá, daquela margem daquela que tava 680, aquela lá.
Esse cheiro de queimada é da cola que tem no buquê.
É tipo de um verniz, não é?
É, fita crepe, então. Cadê o ar? Estou baixando a tensão.
Ah, intermediário já pode marcar.
Tá marcando muito calor, depois não tá vendo aí. Nossa, é muito ignorante essa sala. Filma o perímetro lá, Tito. Filma o perímetro lá.
Aonde? Lá?
Aqui, ó. Filma aqui, ó. Tem evidência, vai lá.
Ó, aqui, ó, cada vez caindo mais. E aqui cada vez subindo mais. Está estabilizando agora. A 680 a 700.
Vamos aqui.
You can see how they feel it around.
Essa volume.
É 680 a 700 aí.
Fica com a cara muito perto, aí pega essa porra esquerda na hora que chega no final.
Minutos e meio.
740 amperes. Vamos lá.
740 amperes, 21 volts.
Está quase 800 amperes.
Nossa, subiu mais agora.
So that is the
Tem que deixar ela
process.
A
resfriar.
fossa já está bem aí, tá?
ඉලෙක්ට්‍රොස්ලැක් වෙල්ඩින් මෂින් එක මෙහෙනම් නැහැ right? හරි මම ඒක අයි පාරක් කියලා දෙන්න මොකක්ද වෙන්නේ කියලා right? මම ඒක මම කියලා දෙන්න ඔක්කොම ටික right? Then in the process start as a arc, as the arc is initiate right? So we have this electrode right? We have electrode so not electrode, this the wire right? The wire is at first it becomes melt right? පළවෙනිටම අපි දෙන wire එක melt මේ එකකින් හැදෙන arc එක නිසා, right? Due to this I mean we have supplied power, right? We have supplied power, right? And from that power you can melt the this wire reel by an arc, right? පළවෙනිටම හැදෙන්නේ එතනදි වෙන්නේ arc එකකින් melted, right? ඊට පස්සේ the arc the arc sorry wire එක නෙවෙයි sorry මම I මුලින්ම කියලා දෙන්න, right? මම මුලින්ම කියලා දෙන්න, right? So this is the electroslag welding, right? So we are using this electroslag welding to it's a type of welding method. Okay, so in this welding method we have a reel of wire, right? We have a reel of wire, and it is fed. I mean, it is fed into this this electrode, right? This welding gun, right? Then we supply power, and from that it will create an arc, right? එතනින් අප power එක දුන්නම එතනින් හැදෙනවා arc එක. ඒ arc එකෙන් මේක ඇතුළේ අපි දාලා තියෙනවා slag flux එක, right? ඔයගොල්ලෝ මතකයිනේ මෙන්න මෙතන මේ වගේ දානවා, right? In the major down, right? You can see we load the granules of flux, right? Into this electroslag area, right? They in this area, right? Due to that arc, right? Due to that arc, it will become mold. ඒක mold melted, right? Melt වෙලා මෙන්න මේ වගේ area එකක් හැදෙනවා, right? It forms this one, right? මෙන්න මේ වගේ slag pool එක නැත්නම් slag area එකක් හැදෙනවා. Then after that, what will happen, right? Then the arc heats the granulated flux and melt it is to form the slag. As sufficient volume of slag is created, the conductive slag extinguishes the arc, right? So due to this arc, due to this slag, you cannot make the arc anymore, right? තවදුරටත් ඒ arc එක හැදෙන්නේ නැහැ. The existing slag keep molten by the resistance of the slag, right? So we have maintained, right? We have maintained the voltage difference. මෙතන මේ දෙපැත්තේ voltage difference එකක් තියෙන්නේ, right? අන්න ඒක නිසා මෙතනින් හැදෙන wire එක melt වෙවි මොකද වෙන්නේ මෙතනින් deposit වෙනවා, right? So that is the electroslag welding. Okay, the existing slag is kept molten by the resistance of the slag as the electrical current passes between the electrode and the workpieces, right? මෙන්න මේක හරහා, right? It will start to conduct electricity, right? දැන් current එක දැන් arc එක නිසානේ මේ weld වෙන්නේ මෙන්න මේ අතට නැත්තම් මේක අයින් කරන්නම්කෝ. මෙතන melt වෙලා මෙන්න මේ අතට, right? මෙන්න මේ අතර current එක යනවා, right? Due to the resistance, it will create heat, and from that, the wire is melted. Okay, so that is the electroslag welding. හරි නේද? ඒක තේරුණාද කියලා දුන්නේ? Did you understand? කවින්ද? Okay, right? I think you got it. Okay. Then after that, you can compare, right? The electro gas welding, this one, and electroslag welding, right? You can compare, right? It is almost similar, right? ඒක ගොඩක් ඒක සමානකම් තියෙනවා, right? You can compare, right? In the electroslag welding, right? Electro gas welding, right? This is gas welding, electroslag welding, right? In the electro gas welding, used an arc to conduct current and melt the flux cord electrode to fill the welding gap, right? මෙතනදී උනේ මොකද්ද? මෙතනින් අපි current එක supply කරලා here, right? We have supplied the current, and you can melt the wire and deposit we can deposit in this area. In the electroslag welding, right? In the electroslag welding, what happened? Use the arc initially, then uses conductive slag to pass the current, and due to the electrical resistance, produce the heat and melt the filler material. Okay, so this happens because of the arc, right? Make a සම්පූර්ණයෙන්ම වෙන්නේ arc එකකින්. මෙතනදී වෙන්නේ මොකක්ද? Right? මුලදී arc එක පාවිච්චි කරනවා. පස්සේ resistance එකෙන් හැදෙන temperature. නැත්තම් ඔයගොල්ලෝ දන්නවනේ. Right? You know that if you pass a current through a resistor, it will create heat, right? So same thing happened due to the resistance in the electrical resistance in the slag, it will generate heat. From that, you can melt the material. Okay, so that is the difference. Okay, did you understand so far? Did you understand? So if you if you did understand, please put yes or else no. I will explain it again. ඔගොල්ලන්ට තේරුණා නම් yes කියලා දාන්න. තේරුණ නැත්නම් no කියලා දාන්න. මම ආයෙ පාරක් වුණා කියලා දෙන්නම්. Okay, right? Right. Okay. So that is the difference between electro-gas welding and electro-slag welding. Okay. So these two are not available, right? These are not available. Not available now, right? But in future, sometimes they will. Okay. The next thing is the next topic I'm going to discuss with you is TIG welding, right? Tungsten arc welding, gas tungsten arc welding. We call that one as GTAW or simply TIG welding. Also known as tungsten inert gas welding, TIG welding. Arc weld is formed between a non-consumable tungsten electrode and the workpiece, right? Here, we are using a non-consumable tungsten electrode, right? Because tungsten I think it has the highest melting point, right? I think. Okay, so it's a non-consumable electrode. In there we are using a non-consumable tungsten electrode and a workpiece. Okay. Filler material is supplied from a wire and similar to the metals to be welded, right? So අර ඔයගොල්ලෝ කලින් මතකයිනේ filler material එකක් wire එකක් විදිහට සමහරට use කරා, right? Especially in the gas, right? Oxyacetylene welding, right? You can remember. Okay. So similarly, you can use a filler rod. Okay. I will delete these unwanted things. Right. So you can see that the filler rod here. You can see the filler rod. You can you can melt this filler rod and deposit on the weld area. And this is the tungsten arc welding welding torch head. Okay, and we provide power, right? There is a power line, and we are using a shielding gas. Okay, shielding gas is usually argon or helium, right? Argon hari helium hari tamai use karna. Those are inert gases, and there will be no slag formation. Commonly used in stainless steel industry, right? We are using this kind of tungsten TIG welding in the to weld stainless steel. Okay, I will show you the process.
What is TIG welding? TIG stands for Tungsten Inert Gas Welding. The American Welding Society calls this process gas tungsten arc welding, or GTAW. You might also hear it called heliarc welding. TIG welding uses a tungsten electrode, and tungsten has an extremely high melting point. When you TIG weld, the electrode gets hot, but it doesn't melt. We say that it's a non-consumable electrode. That doesn't mean it lasts forever. That just means that it doesn't melt and become part of the weld. You see, in a lot of other welding processes, the electrode melts and becomes filler metal. Those are consumable electrode processes. So here's the tungsten electrode being held in a TIG torch. The electrode slips into a collet, and the collet tightens up against the collet body. You can adjust the length that the electrode sticks out of the holder by loosening up the end cap. When you tighten the end cap, the collet clamps down on the electrode. TIG works by melting the base metal, and that is the metal that makes up the two pieces that are to be joined. The heat is generated by an electric arc that forms between the base metal and the tungsten electrode. You can control the amount of heat with a foot pedal or with a thumb wheel on the torch. For most metals, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always the negative and one is always the positive. In DC TIG welding, the electrode is usually negative and the workpiece is positive. The term DCEN is used for this, indicating that the current is DC and the electrode is negative. This is also called straight polarity, but DCEN is a more descriptive term. DCEN puts most of the heat on the workpiece, and it's the most common setup. When welding aluminum, however, AC is used. In AC, the positive and negative voltages switch back and forth between the electrode and the workpiece. And this puts more heat on the electrode, but it has a cleaning effect on the workpiece. You see, aluminum forms oxides that float to the top of the weld pool and prevent a good weld. AC current helps control these oxides. In an electric circuit, the current flows in a loop. In TIG welding, the current has to flow in a complete circle from the machine to the torch, into the work, and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. Now, you can TIG weld with or without filler metal, and that's not a choice you have in a lot of other processes. If you want to add filler metal to a TIG weld, use a filler rod, which is just a rod of metal with a specific alloy. You want to make sure that the filler metal you're using is compatible with the base metal and that it has the strength required to do the job. In TIG welding, the molten metal is protected by a shielding gas. This gas, usually argon and sometimes helium or other gases, keeps the molten metal from reacting with oxygen, water vapor in the atmosphere. This shielding gas is stored in high-pressure cylinders like these. The pressure is reduced to a usable level by a device called a regulator. The shielding gas flows through a hose and comes out right at the point of the weld. So in summary, TIG welding is an electric arc welding process, uses a non-consumable tungsten electrode, the filler metal is added separately in the form of filler rod, and the shielding gas comes from a high-pressure cylinder.
Okay, right? So that is the TIG welding. Okay, that is the TIG welding. All right. Then I will remove these unwanted things. Right. The filler material may not be necessary for TIG welding. The pieces can be fused by also by melting the groove together, right? ඕගොල්ලන්ට සමහරවට දැන් ඒක අත්‍යවශ්‍යම නැහැ. right? filler material මෙන්න මේ විදිහට. filler rod එකක් ඕන වෙන්නේ නැහැ. ඕගොල්ලන්ට පුළුවන් දැනටමත් තියෙන weld එකෙන්ම දැනට තියෙන groove එකම weld කරගෙන යන්න පුළුවන්. right? plate දෙයක් තියෙනවා කියලා හිතන්නකෝ. ඒක හැමම weld කරගෙන යන්න පුළුවන්. The pieces can be fused by melting the groove. If a filler is used, it is fed into the molten weld. If a filler is used, it is fed into the molten weld manually and not through the welding torch as in MIG or MAG welding. Right? ඔයගොල්ලෝ මතකයිනේ අර MIG welding වලදී ඒ filler එක torch එක හරහානේ ගියේ. right? අපි මෙතනදී මේක කරන්නේ manually. මේ තියෙන්නේ මෙන්න මෙයාගේ manual. right? පිටින් තමයි. පිටින් අතින් අල්ලගෙන ඒක අපිට melt කරන්න පුළුවන්. weld කරන්න පුළුවන්. Therefore, TIG welding torch has a completely different structure than MIG torch, right? So that torch structure is much more different. Okay, right. Applications, I think I told you that we are using for steel, stainless steel, right? We are using it for stainless steel. Okay, a pipeline building, containers and mixing machines, stainless steel, right? And build steel, aluminum, nickel alloy, magnesium, copper, brass, bronze, and even gold. Okay, so in those applications, we are using TIG welding. Okay. Right. Then next thing is plasma arc, right? Plasma, plasma arc welding. And before that, I think I have a separate one for these properties of material. Okay, there are you know that there are three different forms of material, right? Solid, liquid, gases. Okay, so if you let's say you cannot, I mean, if you supplies some amount of energy to a solid material, okay, මොකක් හරි solid material එකකට අපි energy එක දුන්නොත් ඒක liquid material එකට හැරෙනවා. Right? If you provide further more energy for liquid material, it will transform into a gas. A gas එකට හැරෙනවා. So if you provide more, right, extremely high amount of energy for a gas, what will happen? It will become a state, right? A state of matter called plasma. Right? අපි gas එකට gas විදිහට තියෙන material එකට ගොඩාක් ලොකු ශක්තියක් දුන්නොත් ඒක හැදෙනවා plasma කියලා form එකකට. Right? So we call that one as plasma. Most plasma are created when extra energy is added to the gas, knocking the electron free from that. Right? You know that the atoms, right? They are made of protons and electrons, right? Protons and electrons. Okay. So these electrons, they are in a we call that one as energy levels, right? They are in a energy level. If you supply extremely high amount of energy, what will happen? It will be the attraction between the electrons and protons. They will be, I mean, that attraction will not be there anymore, and it will be, I mean, they are separate, right? ඔගොල්ලෝ දන්නවනේ සාමාන්‍යයෙන් කියන්නේ මෙන්න මේ වගේ positive protons, right? Protons වටේට මගේ electrons තියෙනවා. Okay? Right? Energy levels විදිහට තියෙනවා. Right? Energy levels විදිහට. අපි මේකට අවශ්‍ය කරන ශක්තිය දුන්නොත් මොකද වෙන්නේ? මේ energy levels කැඩිලා මේ electron with proton වෙන වෙනවා. Right? So that formation is called the plasma. Okay? High temperatures often cause plasma to form. Right? ඒකට ලොකු energy එකක් කියලා කියන්නේ ලොකු heat එකක්. Right? ලොකු heat එකක් දුන්නම තමයි එහෙම හැදෙන්නේ. Atoms in a hot gas are moving so fast they collide with each other. They sometimes knock electron loose. එතකොට ඒක අර මම කලින් කියවනේ right? ඒ atoms වල energy එක දුන්නම ඒ energy levels වලින් electrons අයින් වෙනවා. Right? ඒ අතර ගැටීම් ඇති වෙලා නැත්නම් ඒ energy එක අපිට ඒක දීලා ඒ electrons ගැලවෙනවා. right? එතකොට electrons උයි protons උයි නිකන් වෙන වෙනම වගේ තියෙනවා. Right? So you can use that plasma for welding. අපිට ඒ plasma එකේ ගොඩාක් ලොකු ශක්තියක් තියෙනවා. Right? You can do a certain task by using plasma. Okay? So you can direct that plasma into a welded area and you can weld the material. Right? අපි හැදෙන plasma එක අපිට පුළුවන් මොකක් හරි weld area එක weld කරන්න ඕන තැනකට යවලා ඒකෙන් weld කරන්න. Okay? Plasma is ionized hot gas. Two types of plasma arc welding process. Right? There are two types of plasma arc welding methods. Right? Now transferred and non-transferred. Right? In the transferred, you can see we supply the power to the tungsten electrode and the workpiece. Right? අපි මෙතන electrode එකයි workpiece එකටයි තමයි power එක දීලා තියෙන්නේ. Right? ඒ දෙකට තමයි power එක දීලා තියෙන්නේ. But in the workpiece is a part of electrical circuit. Right? It will complete the circuit. Making මේක දැන් සාමාන්‍ය current එක යන්නේ closed circuit එකක් ඇතුලේ. right? The current is usually passing in a closed circuit, right? So due to this arrangement, the electrode or the current will be passing through this circuit, right? Through the plasma and the electrode and the workpiece are the places where we have supplied the power. But in the non-transferred one, you can see that the electrode is not power energized, right? මෙතන ඔයගොල්ලෝ පේනවා. Workpiece එකට මොනවත් power එකක් දීලා නැහැ. But we have given the power within the welding torch. Okay? Arc occurs between the electrode and the nozzle, right? Nozzle එකයි electrode එක අතර. Deep and narrow welds are made by this process at high welding, right? So I have given the power into the electrode and the nozzle of the welding torch, right? So the plasma is generated within this area, right? මෙන්න මේක ඇතුලේ තමයි plasma එක හැදෙන්නේ ඒ speed එකෙන්ම මෙහෙම ගිහලා පල්ලෙහා තියෙන work piece එකේ වදිනවා. But you can see the difference in the transfer, right? Then මෙන්න මේ මෙතන තියෙන potential difference එක හින්දා තමයි මේ plasma එක ඇවිල්ලා මෙතන වදින්නේ, right? මෙතන මේ plasma එක හදලා තියෙන්නේ මෙන්න මෙහාට යන. ඒ වුණාට මෙතනදී, right? You can see that it will be that plasma will be it will be short, right? ඒක අර නිකන් ගිහිල්ලා වදින්නේ මේක මෙතන තියෙන speed එක හින්දා, right? Due to that speed, okay? මොකද මේ plasma particle high vibrated, not plasma particle, plasma, right? Because it consists of these high speed electrons and protons, right? ඒ වගේ අයන ගොඩක් high speed එකෙන් යනවා. ඒ speed එකම හින්දා තමයි මෙතන ගිහිල්ලා වදින්නේ, right? So did you understand? කියලා දුන්නක තේරෙනවා කොහොමද වෙන්නේ කියලා. And in addition to that, we are using a shielding gas, okay, to prevent oxidization of the welded area. Okay. So did you understand? මම කියලා දුන්නක තේරෙනවා. තේරුණා නම් yes කියලා දාන්න, තේරුම් නැත්නම් no කියලා දාන්න. මම ආයි කියලා දෙන්නම්. තේරුණේ නැහැ. කටට තේරුණාද? right? So I will tell you. Okay. මේක තේරුණා නේද? මේක TIG welding එක තේරුණාද ඔයගොල්ලන්ට? TIG welding එක ඔයගොල්ලන්ට තේරුණාද? TIG එක. right? මම හිතන්නේ TIG එක තේරුණා. plasma කියන එක තමයි තේරුනේ. plasma arc welding එක තමයි තේරුන්නේ නැහැ. right? Right. So in the plasma arc welding, right, what we are trying to do here, we try to generate plasma, right? Plasma is a high ionized hot gas, right? Ions එදියට බෙදිච්ච ඒ gas එක gas කියලා කියන්න බෑ, right? ඒක වෙනම form එක, right? ඒක form එක. ගෑස් එකේ තියෙන්නේ atoms, right? ගෑස් එකේ තියෙන atoms. ඒනොට plasma එකේ තියෙන atoms නෙමෙයි. right? මෙන්න මේගේ positive negative ions, right? ඒ වගේ ions තියෙනවා. So these ions they have a very high momentum. right? ඒකේ ලොකු momentum එකක් තියෙනවා, right? They are moving at a very high speed and they have very high temperature, right? Therefore you can use that energy in the plasma to for welding, right? අපිට weld කරන්න මේ plasma use කරන්න පුළුවන්, right? So here in the plasma arc welding, that is what we try to achieve. ඒක තමයි අපි try කරන්නේ, achieve කරන්නේ. So we try to achieve, right? We try to achieve plasma, right? Or plasma gas, you can oils plasma, right? By by giving power, right? We electricity නැත්නම් power එක දීලා තමයි මේ plasma එක හදන්නේ. Okay? So here there are two types of plasma welding methods. Okay? First one is transfer. In the transferred one, we supply the power to the tungsten electrode as the negative end, and positive side, for the positive end, the workpiece, right? මේ කොළ පාටින් පෙන්නන්නේ workpiece, right? This is the workpiece. So if you make this arrangement, what will happen? The plasma, right? The plasma, it will be moving in this direction, right? It is intended to move in this direction. අපි ඒක එහෙම කරන්නේ අපි හිතලම ඒ plasma එක මේ පැත්තට යවනවා. Then what will happen? It will collide on this workpiece, right? Workpiece එක මෙන්න මෙතන වදින, right? මොකද දැන් මෙතන මෙන්න මේ nozzle එක welding torch එක නැත්නම් welding gun එකේ nozzle එකට. එතකොට මොකද වෙන්නේ? මේක ඇතුලේ තමයි මේ plasma වදින, right? So that is the difference. And deep and narrow end welds can be made using this one, right? You can use this one for deep and narrow welds. Reaches temperatures up to 33,000 Celsius, right? ඒ වගේ ලොකු temperature එකක් මේ plasma එක ඇතුලේ හැදෙනවා. I explained you the properties of metal. Application used to weld pipes and tubes of stainless steel and titanium, used to repair tools, die and molds, right? එතකොට මෙතන මේ stainless steel and titanium වලින් හදපු weld pipes, tubes වගේ දේවල් weld කරන්න use කරනවා. Repair tools, right? Die and molds. අච්චු තියෙනවනේ, right? I will explain in upcoming lectures what do you mean by a die and mold. I think I have explained, right? මම කලින් කියලා දීලා තියෙනවා. ඉස්සරහටත් කියලා දෙනවා, right? What do you mean by die and mold? So to make that, to repair them, we can use plasma arc welding. Used to weld or coating turbine blades, right? Turbines or blade වල weld කරන්න coating වලට plasma arc welding. Transfer arc, I told you the difference, right? Transferred arc, we can use it for thick metals, non-transferred for thin metals. Okay. I forgot to show you, right? මම පෙන්නලා හිටියනේ.
Hello guys, welcome back to the another video of Engineers Academy. In this video we will learn another welding process, that is plasma arc welding process. We will check out its principle, working, types, equipments, applications, advantages and disadvantages. But before going to our today's topic, I request you to consider subscribing to our educational channel Engineers Academy. Also press the bell icon to receive latest updates. Plasma arc welding is a liquid state welding process in which the metal-to-metal joint forms in molten state. The hot ionized gases are known as plasma. These hot ionized gases used to heating the work plates, and the joint is created due to fusion. This welding process is same as TIG welding process, except plasma is used to weld the workpieces instead of the arc. Filler material may or may not be used in this type of welding. One big advantage of plasma arc welding is that it uses less current input compared to TIG or MIG processes for produce the same heat. The hot ionized gases are known as plasma. When a sufficient amount of energy provided to any inert gas, some of its electrons breaks free from its nucleus but travel with it. After the electrons leave, the atoms are converted into hot ionized state. It is most common state of matter which is known as fourth state of matter. These ionized atoms have high heat contain which is further used to join two plates. This is basic principle of plasma arc welding. This welding is extended form of TIG welding in which a non-consumable tungsten electrode is used to produce arc. This arc heats up the inert gases which are provided from inner orifice around tungsten electrode. The heating temperature is about 30,000 degrees centigrade at which the gas converts into ionized form. This hot ionized gas further used to create a welding joint by fusion. Now let's check out the equipments used in the process of plasma arc welding. Plasma arc welding process needed a high-power DC supply to generate electric spark in between tungsten electrode and welding plates, that is for transferred plasma arc welding process, or in between tungsten electrode and discharge nozzle, that is for non-transferred plasma arc welding process. One of the main features of plasma arc welding which make it different from TIG is its low ampere welding capability. This welding can weld at low ampere of about 2 amperes and maximum current which it can handle is about 300 amperes. It needs about 80 volts for proper working. The power source consists transformer, rectifier, and control console. This is most important part of plasma arc welding process. This torch is quite similar as used in TIG welding but too complex. It consists 4 main parts which are tungsten electrode, collets, inner nozzle, and outer nozzle. The tungsten electrode is held by the collet. The collet is available in varying diameters. The inner gas nozzle supply inert gases inside the torch to form plasma. The outside nozzle supply shielding gases which protect the weld area from oxidation. These nozzles wear out rapidly. Plasma arc torches are water-cooled because arc is contained inside the torch which produces high heat, so a water jacket is provided outside the torch. Generally, plasma gas is same as shielding gas which is supplied by a same source. Mainly inert gases like argon, helium etc. are used as both inert and shielding gases. This gas is supplied at both inert and outer nozzles. Mostly no filler material is used in this welding process. If filler material is used, it is directly feed into weld zone. There are 2 types of plasma arc welding process. The first one is non-transferred plasma arc welding. In this welding process, straight polarity DC current is used. In this process, the tungsten electrode is connected to the negative and the nozzle is connected to the positive pole. The arc produces between tungsten electrode and nozzle inside the torch. This will increase the ionization of gas inside the torch. The torch transfers this ionized gas for further process. It is used to weld thin sheets. The next one type is transferred plasma arc welding process. This process also uses straight polarity DC current. In this process, the tungsten electrode is connected to the negative terminal and the workpiece is connected to the positive terminal. The arc is produces between tungsten electrode and workpiece. In this process both plasma and arc transferred to the workpiece which increases the heating capacity of process. It is used to weld thick sheets. Now let's check out the working of the plasma arc welding process. This welding works on same as TIG instead, plasma is used to heat up the parent material. Its working can be summarized as follow. First, the workpieces are properly cleaned. The power source supply power which produces arc between tungsten electrode and nozzle, or tungsten electrode and workpiece. The tungsten electrode gives a high intense arc which is used to ionization of gas particles and converts orifice gases into plasma. This hot ionized gas is supplied to the welding plates from a small orifice. The shielding gases like argon etc. are supplied through pressure valve and regulating valve to the outer nozzle of welding torch. These gases create a shield around the welding area which protect it from atmospheric gases like oxygen, nitrogen etc. The plasma strikes the welding plates and fuses it into one piece. Next, the welding torch is moved in the direction of welding. If the welding required filler material, it is fed by the welder manually. This is whole working process of plasma arc welding. This welding is used in marine and aerospace industries. It is used to weld pipes and tubes of stainless steel or titanium. It is mostly used in electronic industries. It is used to repair tools, die and mold. It is used to welding or coating on turbine blade. Now let's check out the advantages and disadvantages of plasma arc welding process. High welding speed. High energy available for welding. It can be easily used to weld hard and thick workpieces. The distance between tool and workpiece does not affect the arc formation. Low power consumption for same size weld. More stable arc produced by plasma arc welding. High intense arc or high penetration rate. It can work at low amperage. Higher equipment cost. Noisy operation. More radiation. High skill labor required. High maintenance cost. So guys, that was all about the plasma arc welding process. If you have any doubts and queries,
Okay,
please
right.
leave a comment below.
So that is about plasma arc welding, right? I forgot to tell you that we are using inert gas, right? Inert gas for both as the shielding gas and to create the plasma gas, right? Plasma gas එකයි inert gas එකයි දෙකටම අපි use කරන්නේ inert gas, right? Helium or argon. Okay, so I forgot to tell you. Okay. So this is the comparison, and this is the comparison of අපි මේ වෙනකන් කතා කරේ fusion welding, right? Up now, what we have discussed was fusion welding, right? Oxyacetylene, flux core arc welding, sheet metal arc welding, gas metal arc welding. Likewise, all the things are fusion welding, right? In the fusion welding, what we try to do was what we did was we try to melt the material, or we try to apply the heat and pressure to form the weld, right? අපි fusion weld එකේදී අපි සාමාන්‍යයෙන් කරේ heat එක හරි pressure එක හරි දෙකම හරි පාවිච්චි කරලා සාමාන්‍ය heat එක ඕනේ, right? heat එක අනිවාර්යෙන් ඕනේ. heat එක හරි නැත්නම් heat එකයි pressure එක හරි ඒ දෙක use කරලා weld කරපු material එකක් melt කරපු එකෙන් weld කරපු, right? So that is the fusion welding. Okay, so this is the comparison, right? This is the comparison of different arc welding method, right? Shielded metal arc welding, submerged arc welding, gas metal arc welding, gas tungsten TIG welding, flux core arc welding, oxyfuel oxyacetylene, right? And also we have electron and laser beam, right? Likewise, there are different ways of different welding methods, right? So this is the comparison, right? This is the comparison. Okay, the operation is whether manual, automatic, or semi-automatic, and advantages, right? The advantages, right? You can see, and the skill level, whether it require high level, medium level, or low level. Okay, welding positions, right? You can do it for what are the positions, right? You can remember horizontal, vertical, overhead, right? Likewise, what are the positions you can do, and what type of AC or DC current, right? What type of current will be used in the welding method. Distortion means it's more like deformation, right? මම කියව මතක තියෙන හරි heat එකක් දුන්නම distort වෙනවා කියලා, right? Distort shape එක වෙනස් වෙනවා කියලා, right? So that is called the distortion. A typical cost of equipment, you can see the comparison, right? The comparison of the that is given in dollars. Okay, the cost of the welding, cost of welding. Okay, right. Then plasma arc welding මම හිතන්නේ ඒක තේරෙන්නේ නැති නේද? ඔයාලට තේරුණානේ? plasma arc welding එකේදී මෙතන තිබුණේ එකයි, right? මේ දෙකේ වෙනස තේරෙනවනේ, right? මෙතනදී අපි power එක දීලා තියෙන්නේ electrode එකටයි work piece එකටයි. මෙතන non transferred එකේදී electrode එකටයි මේ පිටත තියෙන nozzle එකටයි. මේ දෙක තමයි වෙනස එන්නේ. ඊට පස්සේ practical මෙහෙමයි ඒකේ ලියන paper එකක් තියෙනවා. practical workshop technology practical set එකක් තියෙනවා. Okay? Right. Then right. The next thing it's more about it's not about the building methods, right? It's more about the characteristics, right? What are the characteristics of welded areas or welding pipes? Okay. Characteristics of typical fusion welding zone in oxy-fuel gas welding and arc welding process, right? So this is a comparison, right? This is the place, right? This is the place where the welding has been performed, right? When මෙතන තමයි weld එක කරලා තියෙන්නේ, right? You can see this is the fusion zone, which means it is where the material has become melt, right? මෙන්න මෙතන තමයි material එක melt වෙලා තියෙන්නේ. So that temperature distribution you can see. Okay, so here, right around here, it's the normal temperature, right? අපි දැන් පිටත තියෙනවා atmospheric temperature, right? මෙන්න මේ හරිය තියෙන atmospheric temperature. මෙහාට යන්න යන මොකද වෙන්නේ? temperature එක වැඩි වෙනවා, right? You can see that after around this point what has happened, the temperature is increasing, right? It is increasing, right? So this is the original temperature, and after this point onward you can see the temperature is gradually increasing. Temperature at which the base metal microstructure is affected, right? At a certain point, due to this molten metal, the microstructure, right? The structure, the atomic structure of the material or the workpiece, it has been affected due to this welded zone. Then if you move a little bit, what has happened? Melting point of the base metal, right? These metals are they are at molten stage, right? මෙතන මෙලා තියෙන්නේ melt වෙලා. Molten weld material මැදදී මොකද වෙලා තියෙන්නේ? ඒක molten melt වෙලා, right? And you can see this area is called heat affected zone, right? This one. I will zoom out, right? මම මේක චුට්ටක් ලොකුවට ඇඳලා පෙන්නනවා. So in that area, the welded we have right? We have seen that or we have put our molten metal, right? මෙන්න මෙතනදී ඔයගොල්ලෝ පේනවනේ. මෙන්න මෙතනදී molten metal එක දාලා තියෙනවා, right? මෙතන තමයි molten metal එක තියෙන්නේ. Then we have an area called heat affected zone, or we call that one as HA. Heat affected zone. Due to this molten, this molten area, right? This molten area has a high energy, right? High thermal energy. Due to that thermal energy, right? Or that that thermal energy is conducted into some kind of area, right? මේ area එකට conduct වෙනවා, right? අපි අන්න area එකට කියනවා heat affected zone කියලා, right? So that area has a high temperature, but it's less than the fusion zone. Fusion zone එකට වැඩිය temperature එක අඩුයි. ඒ heat affected zone එකේ temperature එක වැඩි. Okay? Right. So in that area, this is defined, right? Temperature at which the base metal microstructure is affected, right? Due to this heat, right? This thermal energy has been conducted into the heat affected zone, and the microstructure of the material, it has become changed because of the heat. Then the grain structure, right? Grain means is the arrangement, right? අපි මෙයාගේ අපි හිතන්නකො මොකක් හරි metal plate එකක් තියෙනවා කියලා, right? You have a metal piece of metal. If you observe by using a microscope, right? අපි මොකක් හරි microscope එකක් බැලුවොත්, right? microscope එකකින් බැලුවොත් ඕගොල්ලන්ට පේනවා grain කියලා දෙයක්, right? මෙන්න මෙයාගේ grains, right? Those are made of atoms. We call them one as grains, right? You will learn them in the, I think, in the properties of material lecture, right? That is called grains. ඒවා හැදිලා තියෙන atoms වල, right? So if you if you change the grain the properties, right? The properties of the grains, right? Or the grain structure, the properties of the material changes, right? A grain වල තියෙන structure එක අපි මොකක් හරි විදියකින් වෙනස් කරොත් ඒක ඒ material එකට බලපාන, right? So that is called the grain structure, right? So if you observe, right? If you observe this grain structure in the heat affected zone, right? මෙන්න මේ heat affected zone එක මෙන්න මේ දෙපැත්තේ තියෙන grain structure එක දිහා ඔයගොල්ලෝ බැලුවොත්, right? ඒකට ඒකේ micro structure එකට මෙන්න මේ හරිය තියෙන එකට වැඩිය වෙනස්, right? So if you observe the grain structure or the microstructure in the heat effector zone, it will be more different, or it differs with the other parts of the material. Okay. Grain structure, a deep well and a shallow well, right? So these are two examples of well, right? මේ දෙක well කරපු තැන් දෙකක්, right? You can see the well profile, right? The well profile in the deep well is more like this. In the shallow well, you can see the weld area is more like this, right? මෙතන නිකන් කෙදුනේ තේරෙනවා. මෙතන නිකන් කෙදුනේ තේරෙනවා. Right? I think you got it. Okay. So you can see the microstructure changes in the microstructure, right? In the deep well, right? You can see ඔයගොල්ලන්ට පේනවා, right? මේකේ microstructure එක තියෙන්නේ මෙන්න මේ අතට, right? In the shallow well, you can see microstructure is more like in this direction. It's because the grain, it's because the grains are arranged in this way. Okay. Note that the grains in the solidified weld area, weld metal, are perpendicular to the interface of the base metal. In a good weld, grain migration will occur to develop the uniform strength of the bead, right? So මම මේක ලොකු කරලා පෙන්නන්නම්කෝ.
Recording stopped. Recording in progress.
Right. So there was some kind of signal issue, right? Sorry about it. Okay. So what I explained in the last was that the grain structure, right? The grain structure in the deep well, you can see it is in this way because this grain structure is perpendicular to this interface. මෙන්න මෙතන මේ තියෙන interface එකට ලම්බක. interface එක මෙහෙම තියෙනවා නම් හැදෙන grains ඒකට ලම්බකව තමයි මෙන්න මෙහෙම තමයි හැදෙන්නේ. Right? So same thing you can see that in this interface. මෙන්න මේ interface එක මොකද වෙලා තියෙන්නේ? මේ grains ටික මේකට lump. Right? So that is the microstructure arrangement in the weld area. Okay. In a good weld, grain migration will occur to develop uniform strength beam. Right. So if you can maintain uniform grain structure, right? You can achieve uniform strength. Right? මම කලින් කිව්වා මතකයිනේ මෙතන මේ grain structure එකේ හින්දා තමයි මේ වෙල්ඩ් වල විතරක් නෙවෙයි ඕන තැනකදී එහෙමයි. Right? ඒ දැනක metal plate එකක් කියලා. Right? Let's say you have metal plate. Right? The strength depends on the strength and there are certain other properties. Right? Those things depend on the microstructure. If you can change the microstructure, that has an impact on the properties of that plate or that material. And fusion welding characteristics, right? So this is about hardness, right? You don't you didn't learn about this hardness under in the properties of material. We have a separate lesson for hardness, right? What do you mean by hardness, right? There are different types of hardness, Rockwell hardness, right? Likewise, there are different hardness types. But I think if I explain here, you won't be able to understand. Okay. So simply keep in mind, right? Keep in mind in the welded area, right? In the welded area, right? So this is the place, the molten metal, right? Or the heat affected zone, right? මේ තියෙන මෙන්න මේ part එක, right? මෙන්න මේ part එක තමයි අඳුරන්නේ. Okay. So in this area, you can see that the hardness changes, right? The hardness value, it has become changed, right? Due to the because the microstructure changes with the properties, right? Weld first one is this one is weld bead on a cold roll nickel strip produced by laser beam, right? That is a separate one. Micro hardness profile across the weld bead. Note the lower hardness of the weld beads compared with the base metal, right? So this is the in this area the hardness is low. In the other areas, right, you can see that the hardness is high. Because of this slow cooling, grain structure is similar to the cast structure. Grains lines parallel to the heat flow because metals are better heat conductors. Grain is parallel to the metal, right? අර මම කලින් කියව කතාවක් තමයි, right? මෙන්න මේ වගේ එකම line එක දිගේ තමයි හැදීගෙන යන්නේ. Right? This is a separate story, right? It's about hardness, okay? So there are different defects, right? Welding defects. And there are different welding defects which might occur if you perform a weld, okay? So this is an incomplete fusion. Incomplete fusion means there are there are places where the materials it has not become molten, right? සමහර තැන් තියෙනවා melt වෙලා නැති තැන්, right? Incomplete fusion in the fillet weld, right? මේ වගේ ඒවට කියනවා fillet weld කියලා. එන්න ඒ වගේ තැන් වල හිස් තැන්, right? melt වෙලා හරියට melt වෙලා join වෙලා නැති තැන් වලට අපි කියනවා incomplete fusion. So B is often termed bridging, right? This one, right? This is called bridging, right? That term is used for that sort of problems, right? Then second one is incomplete fusion from oxidized, so dross at the center of the joint, especially at aluminum, right? So let's say due to oxidization, or let's say it retained, right? It contains some kind of impurity, right? ඔගොල්ලෝ දන්නවනේ අර ඇලුමිනියම් වගේ දේවල් මෙල්ට් කරපුවම උඩ හැදෙනවා ඒකටත් අපි කියනවා slag කියලා. ඒවට ගොඩක් use කරන term එක තමයි dross කියලා. right? dross. ඒ කියන්නේ oxidize වෙච්ච aluminium මෙතන උඩ පාවෙනවා. right? So if you use that molten aluminium for melting, sometimes these dross may get into empty spaces, right? So that may cause an incomplete fusion. Then so that is the problem. And this third one is incomplete fusion in a groove weld, right? මෙන්න මෙයාගේ weld එකක් weld කරද්දී මෙන්න මෙයාගේ groove එකක් weld කරද්දී you can see that there are some empty spaces, right? These empty spaces, they are incomplete, right? It is called incomplete fusion. Okay, so uh, those are some of the fusion welding defects. Okay, right. So up to now, do you understand? මේවා නිකන් කියලා දෙන්න එක තේරෙනවා. මෙහෙමයි මෙහෙමයි දැන් ස්පෙලිං වගේ දේවල්ට නෙමෙයි ලකුණු දෙන්නේ. ඉංග්‍රීසි වගේ සබ්ජෙක්ට් වල ඇරෙන්න, right? ඉංග්‍රීසි වගේ සබ්ජෙක්ට් එකකට ඇරෙන්න සාමාන්‍යයෙන් ඒ වගේ අඩු කරන්නේ නැහැ. මෙයා ටෙක්නිකල් සබ්ජෙක්ට් නේ. ඒ වගේ ફોකස් කරන්නේ ගොඩක් ටෙක්නිකල් ඩීටේල්ස්, right? එතකොට ටෙක්නිකල් දේවල් වරද්දලා ලිව්වොත් තමයි ලකුණු අඩු කරන්නේ. නැතුව වචන වැරදිට ලිව්වත් අකුරු වැරදිට ලිව්වත් මොනවද ග්‍රැමර් වැරදිට ලිව්වත් ලකුණු අඩු කරන්නේ නැහැ, right? ඒකට පුළුවන් තරම් ලියන්න try කරන්න හරියට, right? ඉංග්‍රීසි වගේ සබ්ජෙක්ට් එක තමයි ඉතින් සාමාන්‍යයෙන් aim කරන්නේ. ඒත් පුළුවන් තරම් හරියට ලියන්න බලන්න. මොකද දැන් අපි දන්නවනේ සමහර වචන වල අකුරු වෙනස් කරොත් වෙනම තේරුමක් නෙන්නේ. right? අන්නේ ඒකින්ද ඒ ගැන චුට්ටක් කල්පනාවෙන් ලියන්න. right? So up to now, did you understand? මෙතන එකක් කියලා දෙන්න තේරෙනවද? මයික්‍රෝ ස්ට්‍රක්චර් එකක් කියලා කියන්නේ ඔයගොල්ලෝ දැන් හිතන්නකෝ මෙටල් ප්ලේට් එකක් තියෙනවා කියලා, right? මෙටල් ප්ලේට් එකක් තියෙනවා, right? මේ වගේ මෙටල් ප්ලේට් එකක් තියෙනවා. මෙටල් නෙමෙයි ඕන දෙයක හිමයි, right? ඕන දෙයක හිමයි, right? අපි ගත්තොත් ඔයගොල්ලෝ දන්නවනේ මෙටල් ප්ලේට් එකක් තියෙනවා කියලා හිතන්නකෝ. මේක හැදලා තියෙන්නේ ඇටම්ස් වලින්, right? හිතන්නකෝ කොපර් ප්ලේට් එකක් කියලා, right? කොපර් ප්ලේට් එකක් තියෙනවා, right? කොපර් ප්ලේට් එක හැදලා තියෙන්නේ කොපර් අයන්ස් නේ, sorry, ඇටම්ස් වලින්, right? කොපර් ඇටම්ස් වලින් කියලා හිතන්නකෝ, right? එතකොට ඔයගොල්ලෝ දැන් හිතන්නකෝ මෙන්න මෙහෙම කවදාකවත් මැටීරියල් වල කවදාකවත් මෙන්න මේ වගේ පිළිවෙලට නැහැ, right? මෙන්න බැලුවොත් මෙහෙම පිළිවෙලට ලස්සනට නැහැ. මම ඉන්නකෝ ඔයගලන්ට වෙන ලෙක්චර් ස්ලයිඩ් එකක් වෙනනේ. ඒකේ මම මයික්‍රෝ ස්ට්‍රක්චර් ගැන කියලා දුන්නා ගොඩක්. ඔයගලන්ගේ 3rd year කට්ටියගේ මම ඒකේ මම ඉන්න පෙන්නන්න ඒක. ම්ම්, ඒක නෙමෙයි. අන්න මේක. right? මෙන්න මේක. එතකොට දැන් ඔයගොල්ලෝ බැලුවා, right? ඔයගොල්ලෝ බැලුවා මම මේ ඉමේජ් එකම කොපි කරන්නම්කෝ. මේක 3rd year කට්ටියගේ ලෙක්චර් එකක්. දැන් මම කියවනේ ප්ලේට් එකක් හැදිලා තියෙන්නේ ඒ ඇටම්ස් වලින් right ඒ ඇටම් ඒ කොපර් ප්ලේට් එකක් නම් කොපර් ඇටම්ස් වලින් තමයි හැදිලා තියෙන්නේ right එතකොට ඒක කවදාක්වත් right ඒ මැටීරියල් එක කවදාක්වත් යුනිෆෝම් විදිහට නෙවෙයි ඇටම්ස් තියෙන්නේ ලස්සනට පිළිවෙලට මේ ඇටම්ස් මේ හැදිලා නැහැ මේ මෙහෙම ලස්සනට ගාන්ට උන්නෝ විදිහට මෙන්න මේ විදිහට ඕන තැනක බැලුවොත් එහෙම යුනිෆෝම් ඔන්නෝම ලස්සනට පිළිවෙලට නෑ හැමතැනම right හරිනම් එහෙමනේ තියෙන්න ඕනේ right මේ මෙහෙම බැලුවොත් ලස්සනට මෙහෙම පිළිවෙලට තියෙන කියලා හිතුවට එහෙම නෑ ප්‍රැක්ටිකලි එහෙම නෑ right ඒ වුණාට අපි බැලුවොත් රටා තියෙනවා right යම් කිසි රටාවක් මේ ඔයගොල්ලෝ බැලුවොත් මෙන්න මේ සෙට් එක right මෙන්න මේ සෙට් එක පිළිවෙලට තියෙනවා පොඩි සෙට් එක right පොඩි සෙට් එක මෙන්න මගේ පිළිවෙලට තියෙනවා ආයි බැලුවොත් මෙන්න මේ සෙට් එක මෙන්න මෙයාගේ ඇටම්ස් පිළිවෙලට තියෙනවා right ඇටම්ස් මෙන්න මෙහෙම පිළිවෙලට තියෙනවා right අන්න ඒ වගේ arrangement වලට අපි කියනවා grain එක right material grain එක right ඒ grain එක ඇතුලේ ඒක ඇතුලේ යම් කිසි රටාවක් තියෙනවා right එතකොට ඒවා අතරේ මෙන්න මේ විදිහට යුනිෆෝම් නැති right යුනිෆෝම් විදිහට නැති ලේයර් එකක් තියෙනවා අපි ඒකට කියනවා grain boundaries කියලා right අපි ඒකට කියනවා grain boundaries කියලා අපි බැලුවොත් ඕන මැටීරියල් එක ඔන්න වගේ හැදිලා තියෙනවා එතකොට මෙන්න මේ properties මෙන්න මේ arrangement එක අපි වෙනස් කරොත් right මේ arrangement එක අපි වෙනස් කරොත් මේ මැටීරියල් එකේ තියෙන properties වෙනස් වෙනවා right තේරුණා නේද කවින් තේරුණා නේද එතකොට අපි වෙල් කරද්දි right වෙල් කරද්දි අපි ගොඩාක් ලොකු හීට් එකක් දෙනවනේ. ඒ හීට් එක දෙනකොට මොකද වෙන්නේ? මෙන්න මේ arrangement එක වෙනස් වෙලා strength එක අඩු වැඩි වෙනවා. තේරුණා නේද? හරි නේද කායි? හරිනේ. So do you have any questions? තව මොනවද ප්‍රශ්න තියෙනවද? මේ grains ගැන grain boundaries ගැන ඔයගොල්ලන්ට කියලා දෙයි properties of material මං හිතන්නේ නලින් සර් කරන්නේ නේ. නලින් සර් කරන්නේ නැත්තේ. ඔයගොල්ලන්ට දැනටමත් නෑ මේ මං හිතන්නේ ඊළඟ සෙම් එකේ තියෙන properties of material කියලා එකක්. ඒක හරියනම් ඉගෙන ගන්න ඕනේ ඔයගොල්ලෝ මේකට කලින් තමයි ඉගෙන ගන්න ඕනේ මොකද මේකේ තියෙන සමහර දේවල් ඉගෙන ගන්න ඒ දැනුම ඕනේ right properties of material ඒක properties of material and strength of material right ඒ දෙක ඉගෙන ගන්න ඕනේ හරියනම් මේ මම ගොඩක් දේවල් ඔයගොල්ලෝ කියලා දුන්නා right ඔයගොල්ලෝ මතක තියෙන shear stress ඒ වගේ දේවල් උනත් කියලා දෙන්නේ properties of material කියන subject එකේ right තව මොනවද ප්‍රශ්න තියෙනවද Okay, right. So if you don't have any questions, we can wind up because I mean the next lecture, the seventh one, is a very long one. Okay, it's about I think in the previous one, what we did was fusion welding, right? In the next lecture, I'm going to discuss more about the welding which does not use fusion, right? මං කලින් කියා මතකයිනේ heat එකයි pressure එකයි use කරන්නේ නැතුව වෙල්ඩ් කරන මෙතඩ්ස් ගැන තමයි අපි ඊළඟට කතා කරන්නේ මේ මෙටල් ජොයිනින් part 3 එකේ right එතකොට ඒක ටිකක් දිග part එකක් ඒක සම්පූර්ණයෙන් ඉවර කරන්න බැරි වෙයි okay right it's a separate story but හරි මේ කියලා දෙන ගොඩක් දේවල් තියෙනවා ඒකින්ද මම බැලුවේ වෙන දවසක වගේ try කරලා බලන්න okay So if you don't have any questions, we will wind up, and we will try to do another lecture most probably on Friday, right? බලමු Friday කරන්න. එහෙම බැරි වුණොත් ඊළඟ සතියේ හරි cover කරලා දෙන්න. Okay? So if you don't have any questions, we will wind up. I will provide this recording and lecture note. Okay? මම හිතන්නේ කලින් සැරේ ඔයගොල්ලන්ට දුන්නා නේද? මට මතකෙදි දුන්නා ඔයාලට. In weld workpiece, if it shrink soon on the water, can be cracked with the building part. Yes, that is possible, right? That can happen because uh, I mean, if you I mean, due to water, right? That water suddenly absorb heat from the workpiece, right? From that, it is possible to form cracks in the welding. Usually, we are not doing that, right? In the welding, we don't do that. Okay, we don't put it in the water, right? සාමාන්‍යයෙන් වතුරේ දාන එක කරන්නේ නැහැ වෙල්ඩ් කරාට පස්සේ. හරි මම ක්ලියර් PDF ටිකක් දාන්න. අර මේ annotation නැති ඒවානේ නේද? මෙන්න මේ රතු පාටින් ඇඳලා නැති ඒවානේ. ඒ ටික මම දාන්න. හරි නේද? ඔයගොල්ලෝ ප්‍රශ්න මොනවද තියෙනවා නම් ප්‍රශ්න මොනවද තියෙනවා නම් මට කියන්න, right? Right. If you have any questions, please let me know, right? Okay, so we will wind up for now, and we'll try to do a lecture on this Friday or else in the next week. Okay, and thank you very much for joining, and we will meet.
Recording stop.